Okay, so we're getting close to the end in our attempt to create this ash tree system, which is a generative art system that, for the most part, creates tree-like data structures. It turns out, though, it doesn't have to. Well, data structures, pictures, like if you feed it some weird parameters, you can make this thing produce weird outputs. So the thing in the background here is, um, like that is output from the ash tree system. You just um, tell it to do weird things, and you get. I still think that's pretty. It's just not what I was originally expecting it to, and that's kind of one of my favorite things about doing generative artwork is being surprised at the output. Okay, so where are we up to? Uh, I'm getting tired. So we were talking about iteration, and specifically talking about trying to make this transition from where we started out, which is writing in functions and programming with functions, and thinking about what I think of as functional programming, which is really using functions as things that you can use to supply recipes and things like that. So, in other words, we're doing stuff like map. And that's where I started introducing the functional programming toolkit in the per package. Um, and I want to continue on with that in this video, but I'm going to try and in order to do so, what I want to do is highlight the fact that there are different types of or different kinds of things you might do within a loop, and those things actually correspond to different kind of iteration systems, different kinds of maps, or well, in a second we're going to talk about a thing called a cumulative loop. So here's what I mean. So here is our ash tree system, again reduced to this little sketch. Right, it starts out, we grow a sapling. From that sapling, we do a. I'm just gonna make these things preload. I don't know why. Hold on. There we go. Start again. We grow the sapling. There we go. From the sapling, we apply a grow multi operation, and that grow multi operation is secretly 3 separate grow from operations, and each of those grow from operations is a bunch of calls to those little helper functions that we wrote. And now, from each of those 3 tips, what we've done is each time we call grow multi again. So now we've got 3 new calls to grow multi, and what each of those is doing is calling grow from 3 times and calling the helpers and so on. So when we wrote the grow multi function, when I tried to transform that first loop into a map, the structure of what we were doing was just creating 3 independent things, 3 new tips, and then throwing away the one that we started with, right? We don't actually care anymore about the new the old tips, because as our tree grows, like I have the thing that's come from that first tip, and then I don't need it anymore. Like that part of the tree has already grown. I'm only interested in passing forward the next tips and the next tips and the next tips. So the grow multi loop, once the loop or the map that's being constructed here, can throw away the input once it's done. We don't care about it again. That's a little bit. So we talked about 3 different ways of solving this. First, we talked about a for loop. Then I talked about the map function, and then I talked about the map DFR function, which is a slightly tidier way of doing the same thing. But there's this other loop that we've got in our code, right? And that's the one where we're growing our tree as a sequence of cycles, right? So at cycle 1, there's 1 tip. At cycle 2, there are these 3 tips. At cycle 3, there are these 9 tips. And so what we're doing is we're having this process now, that the process that's growing longwise rather than outwise, if that makes sense, is that loop is behaving in a subtly different way. This is an iterative process that is growing cumulatively. Each cycle is when at each cycle it does something, but we don't want to throw it away, right? We're growing the tree. We don't actually want to lose our history, because the output of this thing is going to be our actual tree, the thing that we want to draw the picture of. So yes, we want to be able to accumulate. So we want to be able to take this set of tips, and at each stage of our tree growing process, we just want to operate on the current tips, but we want to be able to save all of the old ones, the whole tree, as we're growing. So it's a process that starts and it accumulates. So we just keep adding more and more stuff. So this is another, I forgot that I had this slide. So yes, this is another way of saying the same thing, right? The next cycle is going to use the current tips, but not the older tips, but we don't want to lose them completely. We don't actually want to throw them away, because at the end, to draw the whole tree, we need to store all the tips. So let's have a redraw of that. So on cycle 1, there we've got our tip there. On cycle 2, we've got some new tips. On cycle 3, we've got more tips again. So I got like that. And again, what we're doing here is applying, at each step, we're applying some recipe. And our recipe is going something like this. Like, it's taking our old tips plus knowing what cycle number we're up to. It applies the recipe and out comes our new set of tips. Okay, cool. So let's, instead of trying to think about this in terms of loops, let's try and think about this in terms of something like a map. We've got a thing that we feed in at the beginning. Like, so yes, we have to iterate over our cycles. So that's probably going to be the .x input. Like, that's our first thing that we're going to chuck in. Our recipe, however, is a thing that we're going to apply to the tips. And the tips are the thing that are being accumulated. So what we want to do is have a recipe that looks a little bit like this. Our recipe is just going to be, at each step, we want to grow many. But we don't want to grow it in a map. Like, the map function will just mean that at the very end, we'll end up with the last generation of tips, but we'll have lost all the steps along the way. If we want to keep track of those, we need to use a different function or a different type of thing. And oddly enough, there's a function in the Perl package called accumulate, which does exactly that for us. So let's have a go at that. Okay, so where is my code? It's over here in RStudio. All right, so we have something over here. We have our tips as grow sapling. Here is the thing that we are doing in our loop. So what I said is, we've got a thing that we're iterating over. That's the cycle number there. And then we've got our recipe. Notice here, when I wrote it in the for loop, what I was doing is growing multi to create the new set of tips. And then I was doing a second thing to take the new tips and bind them together into this tree, right? So the tree part is growing bigger and bigger and bigger every step, or at least it's accumulating and keeping track of all the past results, because the old tree is always there. The tips, on the other hand, I'm just keeping the most recent ones. The joy and the beauty of the accumulate function is that I don't need all of that. So I can just do this. I can kind of go, okay, tree is accumulate. And what I'm just going to do is go 1, 2, 6, and then I'm just going to chuck my recipe in here. So my recipe now is just going to be, again, I need a tilde, so I want to go grow multi, and I will show you the thing. I could just say I'm just going to put in a dot there. So I'm just going to say we're going to grow multi. It's very tempting to want to put .x in there. That's for reasons that I am going to just sort of sweep under the rug right now. Not the right thing to do. You would actually, if you had to use the .x or the .y notation, you would want to put the .y in there. But for now, let's just use a single dot. And thankfully that will work just fine for us. So I can just now dump all of that. It will on its own, this here is going to be, this little dot is the thing that's going to be accumulating. So that's the thing that's being iterated over at each step. It's the tips that are being iterated over, and the tree at the end is going to be the cumulated set of all of those things. So I can just delete all of that. And in fact, when I think about it, this is kind of looking like a candidate for something I could get rid of as well, because if I just hit enter here, it turns out that there is a .init argument. Okay, let's just expand this out again. So .x there, .f there is our recipe. And what I just want to say is, when we start our accumulation process, what do we start from? The answer is grow sapling. So I'll just go over here and go grow sapling. She says, trying to remember how to spell sapling again. So that can go as well. And now we have something that I think is a much cleaner and visually, interpretable function. Just saying, okay, so what we're going to do is accumulate across a set of 6 cycles or 6 generations. We're going to, at each generation, we're going to take the growing tip of our tree, we're going to split it into multiple things. So we're going to grow multiple tips from every old tip. And then at the end of that process, the thing we're going to end up with is the tree. And what we're going, and the only other thing to add to all of this is saying, well, yeah, but a tree has to grow from something. We need to know what our starting point was. So our starting point was just the grow sapling function. And so now I can just save that. Oh, I've done it again. Save that, clear that, and let's find out whether or not I can remember what the accumulate function does. Have I done this correctly? Control L, clear the screen, go back over here to the ash tree function, I'll source that, and what have I done wrong? It's complained about something. Data must be a data frame or other object coercible to by fortified to a list. This is another one of those ones that is frustrating to me, so I'm going to see if I can debug. It's always an enjoyable kind of a moment. Okay, tree equals grow accumulate, grow tree equals function, what am I doing wrong? So I do love this process of kind of going, I know that I'm doing something wrong and I'm pretty sure it's actually easy. Got it. I know what it is. Okay. This is handy. This is actually a useful thing. All right. So I'm going to not redo this. I'm just going to run with my error. When I ran the map function originally, let's just go back up to grow multi. I just did this, right? I did a map. And what the map did on its own was output a list. But I didn't want a list. I just wanted this one long data frame that's growing. So for the map, there's this handy thing called, there's the map DFR variant that collapses it to a single data frame. That's kind of what I wanted to do here as well, because what accumulate is going to do is just the same as map. It's going to get me each set of tips that it generates at each cycle is just being chucked into one big list. So tree was actually a list of tibbles. I get a list, and I don't want that. I just wanted one big tibble. So why don't I just do tree? I forgot this line here. Tree is, if there was a accumulate DFR function, we could do that, but accumulate doesn't come in all those different versions. So it's a little bit like you're just working with the basic version of map. So we have to do the extra step of going bind rows, trees into there. So hopefully, bind row tree, the plural error again. So we do that. We go back over here. Let's try and source that. And I think now we had something that worked. Probably. Possibly. Let's check it. Let's run it again, shall we? Oh, has my screen frozen? It has. Okay. Once again, my screen froze. I'm not sure whether you saw all of that, so let me just clear this. No idea what's going on with my machine at the moment. It's very, very unhappy with me. Okay, so let's go, Control Shift S, resource it, and there we go. Now we've got our tree. So it's been, we've taken that loop that we had in that for loop, and this time we've turned it into an accumulate structure, so that at each step it's growing from the tips, but it's accumulating all the history of all the growing tips that our tree has had, and that actually is the whole tree. And so we're now basically at the point of kind of going, well, we have made something that looks an awful lot like a tree. So in one sense of the term, we're done. We've got one more stage, one more video that I'm going to do, which just talks about cleaning some of this up and making it a little bit prettier. But then we'd be done. All right, I'll stop this one here.